Okay, for those who have logged in, good afternoon again. So just a small, quick, you know, summary of what we're going to do in the session. So most of my session is going to be a little heavy in terms of questions because I'm going to focus on takebacks on certain questions and then give you like a blanket strategy that you'll need to follow when it comes to questions of that type. So just a few rules before we get into the session. One, see, we want to get the best out of the session, right? So any sort of doubt that you want to get clarified, just hold on for me to complete the explanation of the question before you ask me a particular doubt. Okay. If there is a lag of around 10 seconds, quickly ping me in the chat window and also log out and log in. That should normally fix the issue. All right. So the session is normally scheduled for 90 minutes, but normally my sessions would spill over by another 15-20 minutes or so. So approximately this would go for around 2 hours. Just keep yourself free till around 4 p.m. Some information about Crack Verbal. I think for those who are our students, I don't need to give you an introduction about us, but for those who are not associated with us, right? And we are founded in 2006. We've catered to almost 6,000 students in 37 different countries, right? Because we also offer an online course. We also provide personal tutoring to students, say in Brazil, US, and other parts of the country. There's also a very good workshop we are scheduling, and this is beyond the 31st of March in Bangalore for those who are in Bangalore. For those in Mumbai and Delhi, 7th April and 8th April would be the dates. So we normally organize this MBA Achiever Summit every year, where we bring in speakers, right? And speakers would be students of ours who have got admits to top universities. So they would give you like a good insight on how they went about their prep. We would also bring in certain speakers from ISB, some speakers, some ex Crack Verbal students from say INSEAD and so on, just for us to interact with all students and help you achieve your goal. Right, so just note the dates, guys. In Bangalore, this would be in 31st March at the Nahar Heritage. I think you will be already be sent mails for an invite to these sessions. For people in Mumbai and Delhi, Arun is going to come down there with a couple of speakers to do the sessions there. Okay, so you would get invites for all of this. Now, just a quick free resources to get you started. We have a lot of free resources online, which we definitely recommend that you use. We have, you can go through our online course. You have a good 3-hour discussion on data sufficiency strategies that is available for all students to view free of cost. We have a lot of blogs. We have a lot of ebooks that you can download. We also have a lot of blogs for application services. So anybody, with doubts on particular colleges, what course to apply for, we have blogs on that. All you have to do is go onto the website and search for all of this. Okay. So I'm just giving you like a run through. And we also connect with students online through strategy videos on YouTube. So just quickly go to our YouTube channel. Arun again speaks there about certain tips to prepare, what colleges to apply, a breakdown on certain colleges like Emory, like UCLA Anderson, and so on, right? So just go to the YouTube channel. You'll find a lot of resources there that you can make use of, right? That's a very quick intro. I don't want to go too much into, details. So let's get started with the actual, portion of this webinar. And that would be how to look at hidden clues in a question. So this is going to be the agenda of the session. All right. I'm going to give you a question. I'm going to give all of you all a couple of minutes to solve. But again, the take back would be in terms of how to approach the question, right? What pieces of information in the question that you can use to your advantage to cut down the working of any question. All right. So I don't want anybody to give me an answer until I ask you to do so. Just please hold on from typing the answer in the chat window. If you're done with the question under 2 minutes, there will be a point I'm going to ask you for your answers. That's when you type it in the chat window. All right. So guys, here's your first question, starting off with an easy one, but there's a lot of take back in this question. Your time starts now. Okay, guys, you can start typing your answers in the chat window if you're done. Final 30 seconds, last call for answers. Guys, don't shy away from putting in your answers, okay? Remember, the entire session is going to depend upon what you take back from each of the questions, okay? That's more important. So directly, whatever answers you get, just randomly put it into the chat window so that we can have a discussion at the end. All right. So looks like most of you all are struggling with this question. I said I'm going to start with an easy one, and then you're scratching your head on, how did he say this was easy? See, I'm not going to work out the questions in the normal conventional approach of solving. Okay, that's not going to be the purpose of this session. I'm going to focus on how can I leverage the information that the question provides and then get to an answer in a much more smarter way than going through the entire mathematical process of working. Okay, so this is what I'm going to start off with. So we have two people, Jennifer and Peter. The first line of the question says, Jennifer has 40% more stamps than Peter. So if I take the number of stamps Peter has as X, then I know that Jennifer should have a total stamps of 1.4x, right? Now I said again, I'm not going to work this entire question by the normal conventional procedure of working. I'm going to leave that up to you. But what I'm going to focus on is how do I leverage this piece of information to get to my answer in a much smarter way than to actually solve for 1.4x. Remember, the question is asking me how many stamps did Jennifer begin with? So I know that the question is asking me for the value of 1.4x, right? Now, the first strategy, whenever you work with questions on the GMAT, sometimes it always makes sense to look at the answer choices. It's better to look down rather than to look up to get to an answer. All right. So always make sure that you look down rather than look up to get to an answer. For example, the amount of stamps Jennifer has is going to be 1.4x, right? So if the number of stamps Jennifer is going to have is going to be 1.4x, the total number of stamps that she's going to have should be divisible by 14. And any number which is going to be divisible by 14 should also be divisible by 7. So now I know for a fact that the number of stamps Jennifer has should be a number which is perfectly divisible by 7. So I'm going to look at my answer choices, right? 140 is definitely perfectly divisible by 7, so I hold on to it. 175 is also perfectly divisible by 7, so I'm going to hold on to that. 200 is a very illogical pick because it is not divisible by 7. 220 is also a very illogical pick because it's not going to be divisible by 7. 245 is a number which is definitely divisible by 7. So just by correlating the information that the question gives me to find out the number of stamps Jennifer has to have, I know that the number of stamps Jennifer should have should be a multiple of 7. So the first take back is, whenever you're given information about fractions in a question or percentages in a question, remember you can always change a percentage, always change a percent into a fraction. And when you change a percentage into a fraction, the denominator of the fraction gives you huge pieces of information of what the answer can actually be. So just by looking at this first part of the question, I could have eliminated answer choices Charlie and answer choices Delta because they are not multiples of 7. Okay with this, guys? Okay with this? Okay with this first understanding of how I correlated the information and I looked at my answer choices and I eliminate C and D directly? All of y'all? Perfect. Now, what would I do from this point? What would I do from this point? I have answer choices echo, I have answer choices beta, and I have answer choices alpha to work with. So it makes more sense for me at this point to use my answer choices and try to see which answer choice matches the information that the question provides, rather than me sitting and creating the equations and trying to solve the equation, right? So now I'm going to take answer choice alpha, right, 140. And I'm going to look at how to solve with that. So basically I have 1.4x to be 140. So x is going to be 140 divided by 1.4. So x is going to be 100. So taking the first answer choice alpha, I know Jennifer's stamps would be 140 and Peter's stamps would be 100. Now I know the first part of the question says if Jennifer gives 45 of her stamps to Peter. So if Jennifer transfers 45 of her stamps to Peter, the number of stamps she's going to end up with is 95. And the number of stamps Peter is going to end up with is going to be 145. And if this transfer takes place, then Peter should have 10% more stamps than Jennifer. Clearly 145 is not 10% more than 95. So I can eliminate answer choice alpha. If I take 175, 1.4x is equal to 175. So x is going to be 175 divided by 1.4. So 14 ones are 14, 14 twos are 38, 28. I'm left with 7, 14 fives are 70. So if I take answer choice beta, Jennifer is going to have 175 stamps and Peter will have 125 stamps, right? Now if Jennifer gives 45 of her stamps to Peter, she's going to lose 45 stamps, so she's going to end up with 130. And Peter is going to gain 45 stamps and he's going to increase to 170. For this to be my answer, Peter should have 10% more stamps than Jennifer, right? So 170 is definitely not 10% more than 130. So I can eliminate answer choice beta. So the only logical pick here, or the only left out answer that I have would be answer choice echo, which is 245. So the first take back in a question is whenever you see a question with percentages or fractions involved, keep in mind that the denominator of the fraction gives you huge pieces of information on how to proceed with the question, right? So you always make use of the denominator to figure out what can be logical picks and what can be illogical picks. See, how to decide, that is more to do with practice, right? I'm saying that if I look at a question, you should get into the habit of always looking at the question, correlating the information, and then looking at the answer choices. Okay, then looking at the answer choices. So that would depend upon the question and the answer choices. So you will have to think about, never look at the GMAT exam in terms of a mathematical exam, right? It's more of a reasoning test. So if you're able to reason out certain things from the question, it's easier for you to get to an answer directly. Okay with this, guys? All of y'all? Okay with this first question? So the first take back is always hold on to the denominators of all the fractions or percentages that you have. It gives you huge pieces of information. Perfect. So just since we are on the same note, right? Just since we are on the same note, I'm going to quickly give you another question, which definitely I would classify as a 700 level question here, right? Let me write it down for you. In a class of 16 students, 1/5 of the boys are shorter than the shortest girl in the class, and 1/3 of the girls are taller than the tallest boy in the class. What percent of students are taller than the shortest girl but are shorter than the tallest boy? Answer choice alpha 62.5%, beta 67.5%, Charlie 75%, delta 77.5%, echo 80%. So what I want all of you all to do is take back what we discussed in the previous question. Think through the question, try to look at what information you can glean from the question itself, then work your way through the question and give me an answer, okay? So your 2 minutes on this question starts now. Okay, guys, you can start putting your answers in the chat window. Another 30 seconds. Guys, like I said, the entire webinar is focused on how you break down the question that is given, okay? So focus on that. How exactly do I leverage the information that is given in the question to get to an answer in a much easier way rather than going by a conventional procedure of using B, G, and so on. All right. So I see most of you all have given me echo as the answer. Some have given me Charlie. A couple of you all have given me alpha. Now, like I said, right, in the previous question, the biggest take back, and this is something that will always help you out on the test. Whenever you deal with a question where you have fractions, the denominator is always your friend. Okay, the denominator is always your friend, the denominator of the fraction, because it's going to help you out to logically figure out what are the possibilities rather than mathematically figure it out, right? Now look at the question, please. I'm going to break down the information that is given in the question stem. We have a total of 16 students. And the question says, 1/5 of the boys are shorter than the shortest girl in the class. So if I'm taking 1/5 of the boys, the number of boys has to be a multiple of 5. And the second part of the question says, and 1/3 of the girls are taller than the tallest boy in the class, right? So I know the number of girls, since I'm taking 1/3 of the girls, has to be a multiple of 3. So remember, the total number of boys in the class now has to be a multiple of 5. The number of girls in the class has to be a multiple of 3. And I should have a total of 16 students, right? So think about it. How can I split the 16 students into boys and girls such that I get a multiple of 5 and a multiple of 3, which adds up to 16? Think about it, guys. How would you split this up? How would you split 16 students into a multiple of 5 and a multiple of 3, which adds up to 16? Perfect. So I can only get 10 boys and 6 girls. That's the only possibility of me splitting up the total number of students into a multiple of 5 and a multiple of 3. Because if I need the number of boys to be a multiple of 5, the only possibilities they can take would be 5, 10, and 15. If I have 5 boys and the total of students are 16, then I should have 11 girls, but 11 is not a multiple of 3. If I have 10 boys, I'm going to get 6 girls. If I have 15 boys, then I'm going to have only 1 girl in the class, right? So clearly, just by looking at the information, leveraging the information that the question provides in terms of the fractions, the denominators of the fractions to be more specific, I've quickly figured out how many boys and how many girls are there in this class. So I'm not going by the conventional way of taking the number of boys as B and the number of girls as 16 minus B or G and working with it, right? I'm just using the information, getting to an answer quickly, and then using the remaining part of the question to get to what the question asks me to find out. So the question now asks me, what percent of students are taller than the shortest girl, but are shorter than the tallest boy? So I'm going to keep the shortest girl as SG here, and I'm going to keep the tallest boy as TB here. The question says, 1/5 of the boys are shorter than the shortest girl. Now I know the number of boys is 10. 1/5 of 10 is going to be 2. So I have 2 boys who are shorter than the shortest girl. And 1/3 of the girls are taller than the tallest boy in the class, right? Now, total number of girls is 6. So 1/3 of 6 is going to be 2. So I'm going to have 2 girls who are taller than the tallest boy. Now, what does the question ask me to find out? The question asks me to find out what percent of students are taller than the shortest girl, but shorter than the tallest boy. It's a very, very, very simple question based on percentages. The question asks me how many students are between the shortest girl and the tallest boy. I've already taken care of 6 students here. Obviously, I have a total of 16. So the number of students in between the shortest girl and the tallest boy is going to be 10. For those of you all who give me 75% as the answer, you all included the shortest girl and the tallest boy. That's not what the question asks you. The question asks you how many students are taller than the shortest girl, but shorter than the tallest boy. So I need to find out how many students are between them two. So the question is just asking me 10 is what percent of 16? So 10 by 16 into 100, 4 4s are, 2 25s are, 2 2s are, 2 5s are, gives me 125 by 2, which is 62.5%, which gives me the answer to be alpha. So the first huge take back whenever you see a question where you have a fraction is the denominator of the fraction will always give you a big clue of how to proceed with the entire question, right? So instead of you starting the question with jumping into variables, it's always better to use a logical analysis to figure out what possibilities can you have for boys and girls, right? When you have a total of 16 and you need to take 1/5 of the boys and 1/3 of the girls. Okay with this, guys? You understood how I split up the 16 as 10 and 6? It was a very, very logical analysis based on the information that the fractions provided to me, right? Okay with this, guys? All of you all? Perfect. Ankita, it's very simple, right? I have 16 students. I need to take 1/5 of the boys who are shorter than the shortest girl. So the number of boys has to be a multiple of 5, right? So the only possibilities would be 10, 5, 10, and 15. And the number of girls has to be a multiple of 3 because that's the only way I can take 1/3, because boys and girls by default have to be integers, right? So if I take 5 boys, if I take 5 to be a possibility for the number of boys, since I have a total of 16 students, the girls would be 11, which is not possible because I need a multiple of 3. If I take 10 boys, I'm going to get 6 girls. This is a definite logical pick because 1/5 of 10 I can find it as 2, and 1/3 of 6 is also 2. If I take 15 boys, I'm only going to get 1 girl, right? I cannot do 1/3 of 1 girl. That doesn't make sense. So the only logical number, or to split up the 16 students to take 1/5 and 1/3, would be 10 and 6. Okay with this? Perfect. Okay, she's asking why 10 out of 16 and not 12 out of 16. Perfect. So it's very, very simple, right? Let me, refresh the page. 1, 2, 3, 4, 5. If I give you A, B, C, D, and E, and I ask you how many students are between A and E, what will be your answer? If I ask you how many students are between A and E, the answer would be 3, right? You're not going to include A and E, right? So if I give you the shortest girl and I give you the tallest boy, and I tell you how many students are taller than the shortest girl but shorter than the tallest boy, that basically implies how many students are between the shortest girl and the tallest boy, right? So I don't include the shortest girl and the tallest boy in this point, right? Got this, Ankita? Right? You don't include the shortest girl or the tallest boy because they ask me how many are taller than the shortest girl but shorter than the tallest boy, isn't it? Perfect. So remember, guys, the first take back, denominators of fractions are always your friend, okay? So make sure you use them wisely. Perfect. So here's your next question. Your 2 minutes start now. All right, guys, you can start typing your answers in the chat window, please. All right, so I see a lot of y'all have given me an answer, Charlie. There's been quite a few of y'all who've given me beta also as the answer. See, again, I told you, right? The process that I'm going to deal with here is not going to be the conventional procedure to get to an answer. For those who worked it out conventionally, then I'm not going to deal with that, right? What I'm going to deal with is how, again, to leverage the information that is given in the question and get to an answer. By the way, this is an official GMAT question. Even the answer choices are exactly the same. So let's look at how exactly you need to proceed with this, right? The question says if each term in the sum A1, A2, A3 till AN is either a 7 or 77, right? So 7 or 77, remember I can take any possible number I want, and the sum equals to 350, which of the following could be equal to N? Now, like I said, right, you'll have to get into that habit of always glancing at your answer choices, because the answer choices gives you huge clues of what can be an answer. Believe me or not, you can answer this question in 20 seconds, right? If you work with the answer choices and got to an answer from there. See, I know that the numbers that I can take can be 7 or 77, right? So I'm not going to list out the possibilities and so on. I know that the sum of all of these numbers has to be 350, and the units digit of this entire sum is 0. Now, when I add sevens, right? If I take 1 7, the unit digit is not going to be 0. If I take 2 sevens, 7 into 2 gives me 14, which is not going to end with 0. If I add 7 plus 7 plus 7, it's going to give me a 21. If I add 7 plus 7 plus 7 plus 7 plus 7, it's going to give me a 28. Basically, if I add a continuous string of sevens, the only point I can get a 0 as a sum is if I have 10 sevens, right? So the only way I can get the 0 at the end, right, is if I have the number of sevens to be a multiple of 10. And there's only one logical pick here, which gives you a multiple of 10, and that would be 40. So whenever you get questions where you need to end up doing a lot of calculations to get to your answer, right? The best thing to do to bypass the calculations is to always glance at your answer choices. As soon as you see answer choices which have different numbers as units digit, right? Always glance at the units digit of the answer choices. As soon as you see them being different digits, think about using the units digit to bypass the calculations, right? For example, if you're supposed to work with a really ugly permutation question, say in the first scenario you get 36, in the second scenario you get 36 into 37 into 38, in the third scenario you get 36 into 37, and then you need to add all of this up to get to an answer. It's better for me at this point to glance at the answer choices and look at the units digit, because the units digit would give me a huge clue of what can be the logical pick. So the unit digit here is going to be 6. 6 sevens are 42, so the unit digit there is 2. 2 into 8 would give me a 16, so the unit digit would be 6 again. And 6 into 7 gives me a 42, so this would give me a 2. So the overall unit digit would be 6 plus 6, 12, 12 plus 2, 14. So I'm going to pick an answer which is going to end with 4 and move on. If I have two answer choices which end with 4, then you are forced to calculate. The GMAT would want you to calculate. Then you go ahead and do the calculations and get to an answer. But ideally, whenever a question deals with too much calculations, right, they would always place the answer choices in a much friendlier way where you can get to an answer without doing too much of math. And this question is a big example of this. Since I needed the sum to be 350, I know that the number of sevens has to be a multiple of 10, because the only way I can get a 0 as the unit digit is if I have 10 sevens, right? So I have to have the number of sevens to be a multiple of 10, and the only logical pick here was 40. So the take back from this question, whenever you're dealing with too much calculations, it always makes sense to make use of the answer choices, especially the units digit of the answer choices, to get to a very logical answer. Okay with this, guys, all of you all? Any questions on this? Perfect. All right. So here's the next question. A hard one, I would say. So your 2 minutes start now. Okay, guys, you can start typing your answers in the chat window, please. See, for the guys who are new to a data sufficiency, right, you need to understand that this is a value data sufficiency. In a value data sufficiency, I need a definite answer for it to be sufficient, okay, for a statement to be sufficient. So if you get something like x is equal to y, that is not sufficient information, because x being equal to y doesn't give me an actual value for x, okay? Okay, so I see a lot of E's. Some of you all have given me B. Some of you all have given me Alpha. Some of you all also given me Charlie, right? Now, one thing you have to get into the habit of doing, especially at the higher levels of questions, right? And you'll realize what I'm telling you here is very, very important once you work out questions from other topics also. You have to learn to break down the information that is given in the question stem, especially in geometry, right? Especially in the topic geometry, they are not going to spoon feed you with pieces of information. They are going to, purposely hide certain pieces of information just to make the question a little more challenging. So it makes more sense, especially in a geometry question, and as we'll see later in a word problem, to spend some more time on the question stem itself. Now, what does the question stem tell me here? If x minus q is equal to s minus y, it's asking me the value of z. So the mathematician in you will obviously say that, okay, let me take the y to this side and the q to the other. So I know x plus y is equal to s plus q. And they've given me two triangles here, where the first triangle has the angles to be x, y, z, and the second has the angles to be s, q, and r. And I've also been told that in these two triangles, x plus y is equal to s plus q. Now think logically. If in a triangle I give you x plus y is equal to s plus q in another triangle, what can I say about the third angle in the triangles? What can I analyze from the by looking at this pieces of information that is given to me? What can I analyze about z and r? Think about it, guys. If I give you x plus y is equal to s plus q, what can you analyze about z and r? Perfect. That z is always going to be equal to r. Now, this is the hidden piece of information that the question provides me, right? For people who didn't get this, just think about it logically, right? X plus y plus z is equal to 180 degrees. Even s plus q plus r is equal to 180 degrees, right? So if I subtract these two, I know x plus y is equal to s plus q, right? So I can cancel out these. And z minus r is going to be 180 minus 180 is equal to 0. So I know that z has to be equal to r. Now, this is a very critical piece of information that you'll have to use to answer the question, right? So whenever you're working out with questions on geometry or with questions dealing with word problems, right, it always makes sense to spend some more time breaking down the information provided in the question stem. If you break down the question stem, get to the hidden pieces of information, the analysis of the statements become way easier for you to solve. Okay with the first bit of analysis, guys, all of y'all? Before I go into the explanation of the statements, is that okay? Perfect. So I'm going to look at the first statement now. The first statement tells me xq plus sy plus sx plus yq is equal to zr. Now again, what the mathematician in you will tell you to do is to group the terms and take things common, right? So I'm going to group these terms xq and yq, and I'm going to take q common. So I'm going to get x plus y. And out of these two terms, sy and sx, I'm going to take s common. I'm going to get x plus y. And I know that z is equal to r, right? So I'm going to write zr to be equal to z square, because z is equal to r. And remember, I'm trying to maintain z here because the question asks me to find z. I'm going to take x plus y common here. So x plus y into s plus q is equal to z square. So now, since I know x plus y is equal to x plus q, I can write this as x plus y whole square is equal to z square. And I can cancel the squares on both sides because I'm only dealing with positive numbers here. So the first statement gives me information that x plus y is equal to z. Now think logically, okay? If in a triangle, in the first triangle, I have x plus y plus z is equal to 180 degrees, and the first statement gives me x plus y is equal to z, then I can easily say that 2z is equal to 180. So z is going to be equal to 90. So the first statement gives me enough information to solve for the value of z. So the first statement is definitely sufficient. Now let's take the second statement. Second statement says zq minus ry is equal to rx minus zs. So again, I'm going to group the terms zq plus zs is equal to rx plus ry. I'll take z common, s plus q. I'll take r common, x plus y. I know x plus q is equal to s plus y, so I can cancel these two out. The second statement already reiterates what I already know, right? What I already know is z is equal to r. Remember, for those of you all who gave me beta as the answer, right? Z is equal to r is not a definite answer. When I ask you what is the value of z, I need a definite number to be the answer, right? I need a definite answer. Z is equal to r is not an answer because z now will depend upon the value of r, and r can take any random value, right? So I don't get one definite answer for z. So the answer here is alpha. So again, I'm reiterating this. When it comes to questions on geometry, and when it comes to questions on especially data sufficiency questions on word problems, it makes more sense for all of you all to break down the question stem. Spend some more time to analyze the information given in the question rather than jumping into the statements. All right? Because if you do so, the analysis of the statements become way easier for you to solve. Okay with this, guys? All of you all? Perfect. Any doubts on this? Any doubts on why I said the first statement is sufficient and why I said the second was not? Perfect. Okay, so I'm going on to the next question. Let's skip this. And like I said, right, I'm going to deal with questions which obviously have a take back, right? I told you in the previous question that it makes more sense to spend time on the question stem. I'm going to repeat that piece of information here, right? But this question is in the form of a word problem. So I want all of y'all to actually try to break down the question that is given and then look at what the statements provide, okay? You will never fall for traps if you break down the question stem properly. So your 2 minutes start now. Okay, you can start typing in your answers in the chat window. Perfect. So let's have a discussion on this. Most of you all have taken back what I told you in the previous question, spent some more time on the question stem. Some of you all have still not taken back and given me an answer choice Charlie. For those of you all who gave an answer choice beta, absolutely fine. Beta is the answer to this question. Now, like I said, right, you'll always be rewarded if you break down the question stem and try to rephrase the data sufficiency. Try to leverage what information is given in the question stem before jumping into the statements. The question says, in a certain year, the difference between Mary's and Jim's annual salary was twice the difference between Mary's and Kate's annual salary. If Mary's annual salary was the highest of the three people. So if this is given to me, I'm going to create equations from what the question stem gives me, right? The difference between Mary's and Jim's annual salary, I'm going to do it here. That is M minus J. Was twice the difference between Mary's and Kate's annual salary. That's 2 times M minus K, right? Why am I taking M minus J and M minus K and not J minus M and K minus M? Because clearly in the second line, they mention if Mary's annual salary was the highest of the three people. Now the question says, what was the average annual salary of the three people that year? So the question is, what was the average salary? Now the average salary is given to me as M plus J plus K divided by 3, right? This is what I need to find out. So for those of you all who stopped at this point and then directly jumped into the statements, that's the trap that they want you to fall for, because then you would definitely give me Charlie to be the answer if you don't manipulate the information provided properly, right? Don't stop at this point. Always try to break the question down further, use pieces of information together, and then later on work with the statements. Now I can still work with this further, right? I know M minus J is going to be 2M minus 2K. So I can just say that I can take M to the right hand side, 2K to the left hand side, or I can just say that M minus J, M is equal to, or 2K minus J is equal to M, or M plus J is equal to 2K. This is what the question stem provides me. And remember, if M plus J is equal to 2K, what I'm asked to find out is the average, that is M plus J plus K divided by 3, right? And if M plus J is equal to 2K, the average here is going to be 2K plus K divided by 3. Now 2K plus K is 3K. So 3K divided by 3 would give me K. So I know the average salary would be equal to K. And if I have information about Kate's annual salary, that's enough information for me to solve the entire question. So now I'm going to the statements. Jim's annual salary was $30,000 that year. Doesn't give me the value of K, so clearly insufficient. The second statement tells me Kate's annual salary was 40,000. I exactly got what the question asked me to find out. So the second statement is clearly sufficient. The answer here has to be B. So like I said, guys, don't stop at a point, okay? Don't create an equation and stop at a point. Try to manipulate the equations and try to algebraically, solve the equations to see how you can break down the data sufficiency question, right? Because if you do so, especially on data sufficiencies, the evaluation of the statements become way easier to work with. Okay with this, all of y'all? Okay with how I broke down the question? especially the students who gave me Charlie as the answer instead of beta, learn to break down the question. All right. Perfect. So here's your next question. Again, like I said, making sure that you understand what the question provides is key to solving this question. Okay. So spend some time on the question stem and give me an answer. Okay, you can start typing your answers in the chat window, please. Last 30 seconds. All right. So a lot of contradictory answers for this. It's a hard one. Most of the students would have problems, especially with these abstract kinds of questions, right? But remember, like I said, it makes sense first to spend more time on the question stem to analyze what you can about A, B, C, and D before you go to the statements. It's never a good sign, especially for such questions, to work from the statements. Okay. So let's work with this. Most of you all have given me the answer choice to be Charlie. Lots of you all have given me Echo. Some of you all have given me Alpha. Some of you all have given me Delta. right? So let's work with this. I have AB into CD, which is 1995, right? So if AB into CD is 1995, and they've told me that it's a correctly worked multiplication problem, each symbol represents a different non-zero digit. So A, B, C, and D are all distinct digits. And the question is asking me, what is the value of C? Now, the first thing that I would think of doing is I would think about breaking down 1995 into a product of two values. Okay. And the best thing to do is to factorize this. So 5 3s are 15, 5 9s are 45, 5 9s are 45. You can divide by 3, 3 1s are 3, 3 3s are 9, 3 3s are 9. What goes to 133? Anybody? What goes to 133? What would divide 133? 7. So 7 1s are 7, 7 9s is 63, and 19. So 1995 can be broken down into 5 into 3 into 7 into 19. So now what I'm going to do is I'm going to group these numbers such that I get a product of two values, keeping in mind that A, B, C, and D all have to be distinct digits, right? So one possibility is to take 5 into 3, which is 15, and take 19 into 7, right? 19 into 7, 7 9s is 63, 7 1s is 7 plus 6 is 13, which gives me a 3-digit number, so that doesn't absolutely make sense, right? The second possibility is to take 7 and 5, which gives me a 35, and then take 19 into 3, which gives me a 57. But I cannot take 7 into 5, 35, and 19 into 3, 57, because in this case, 5 repeats for both B and C, right? So this is also not a logical choice. But if I take 7 3s are 21, and 19 into 5 is 85, now this can definitely be a possibility of AB into CD. Or the reverse case, right? Or I can also have it to be 85 and 21. Because here in 21 into 85 and 85 into 21, all the 4 digits A, B, C, and D are different. So I know that these could only be the two possibilities of multiplications of AB into CD, which gives me 1995. So now I'm going to work with the statements. I've broken down the entire question to these two possibilities. Now the statements evaluations are going to become very easy for me. The first statement says that D is prime. Now, if D is prime, remember I have two possibilities, 21 into 85 and 85 into 21. If D is prime, the only logical pick I can take out of these two would be 21 into 85, right? Because the only possibility I can have is D to be 5, because D can't be 1. 1, remember, is not a prime number. So the first statement is clearly sufficient to solve. Now let's go with the second statement. The second statement tells me that B is not prime. So if B is not prime, remember 2 is a prime number, 8 is not prime, 1 is not prime, 2 is again prime, right? The question is about B. The statement is about B. B is not prime. So if B is not prime, the only possibility again I can take is 21 into 85, because if I take 85 into 21, then 85, since B here is 5, would go against the statement. So again, the second statement is enough for me to say that AB into CD is going to be 21 into 85. So the only possible value of C that I can get is 8. So the second statement also is individually sufficient. So the answer here has to be delta. Now again, the take back here, guys, is whenever you have abstract questions like this, right, multiplication or addition with certain, alphabets that is given to you, what is key is how you break down the question itself. Okay, because if you start using numbers based on the statements that is given, it's going to take you a heck of a long time to get to an answer. So learn to break down the question and then work with the statements. Got this? Everybody, any particular doubt on this question? It's a hard one, right? It's a hard one. All of y'all? Yes, 19 into 5 is 95, right? Sorry, that's an error from my end. 19 into 5 has to be 95, right? Okay with this, guys? All of y'all? Any particular doubts on this? Okay. Perfect. So here's another good hard question. And remember, like I said, try to get in the habit of analyzing the question first before jumping into the statements. Okay? Get in that habit. Your 2 minutes start now. All right, you can start typing your answers in the chat window, please. Last 30 seconds. Okay, so let's have a discussion on this question. Lots of you all have given me alpha as the answer. Some of you all have given me Charlie. The second favored choice is echo, but very few of you all have given me the actual answer choice. Okay, so let's work with this. See, on whenever you think about question stems, right, what you shouldn't do is you shouldn't forget the fact that when you're working with a data sufficiency, your approach to solve the statements should be to try to always get a contradiction, right? Now let's first break down the question, right? I have A and B to be positive integers. And the question is the remainder of 10 to the power of A, is the remainder of 10 to the power of A plus B divided by 3 greater than the remainder of 10 to the power of B plus A divided by 3? Now, a good test taker would obviously analyze this equation and say that the remainder of 10 to the power of A divided by 3 will always be 1. And the remainder of 10 to the power of B divided by 3 will always be 1, no matter what value you take for A and B, right? So the question basically can boil down to, is the remainder when 1 plus B is divided by 3 greater than the remainder when 1 plus A is divided by 3? For those of you all who are not accustomed to the remainder concept, See guys, when you have two numbers multiplied to each other, right? 15 into 15 divided by 7. And I ask you, what is the remainder when 15 into 15 is divided by 7? You don't need to multiply the terms in the numerator to get the overall remainder. You can always work with the remainder separately. So the remainder when 15 is divided by 7 is 1. And the remainder when this 15 is divided by 7 is also 1. So the overall remainder when 15 into 15 is divided by 7 is 1. And the same concept holds good when you have an addition of values, right? So if you need to find the remainder when 15 plus 15 is divided by 7, the remainder when 15 is divided by 7 is 1. The remainder when this 15 is divided by 7 is also 1. So the overall remainder is going to be 2, right? So you're going to use the remainder concept here to get to an answer, right? So if you need to find out the remainder when 10 to the power of a plus b is divided by 3 and the remainder of 10 to the power of b plus a divided by 3, you can find out the remainder when 10 to the power of a is divided by 3 first, and then when b is divided by 3 to get the overall remainder. And same here, you can find out the remainder when 10 to the power of b is divided by 3 and then when a is divided by 3. But remember, 10 to the power of a divided by 3 or 10 to the power of b divided by 3 will always provide me a remainder of 1. So I'm going to keep that by default as 1. And now the entire question will hinge upon the values of a and b. Now I'm going to go to the statements. Now the first statement says a is greater than b. Now most of y'all came up to this point. For those of y'all, I'm assuming, who gave alpha as the answer, most of y'all, I'm assuming, broke down the question this way, but then you all forgot to how exactly you need to approach a data sufficiency question. Remember, a data sufficiency question should be always approached in such a way that you get a contradiction in terms of the statements. For a greater than b, for example, let me take values, okay? Let me keep a to be 3, right? And b to be 1. If I take a to be 3 and b to be 1, remember the question is the remainder when 1 plus b divided by 3, so it's going to be 1 plus 1 divided by 3. Is this greater than the remainder when 1 plus 4 is divided by 3? Now the remainder when 1 plus 1, 2 is divided by 3 is going to be 2. And the remainder when 1 plus 4, 5 is divided by 3 is also going to be 2, right? So is 2 greater than 2? I get a no. So as soon as you get a no, you should try to contradict that answer by getting a yes. So how do I get a yes? If I take a to be 2 and b to be 1. If I take a to be 2, then this question becomes the remainder when 1 plus 1 is divided by 3 greater than the remainder when 1 plus 2 is divided by 3. So the remainder when 2 is divided by 3 is 2, and the remainder when 3 is divided by 3 is 0. So in this case, 2 is definitely greater than 0. I get a yes. So the first statement is insufficient. I'm left with 3 possible answer choices, B, C, and E. So remember guys, even though you've broken down the question, you can't, go against what the statements always give you, right? Remember, the statements are always true, but when you're plugging in values, you should always try to prove a statement to be not sufficient rather than proving it to be sufficient. Okay, you should always have a negative thought process when you work with the statements. So the first statement is clearly insufficient because it gives me a yes. It also gives me a no. Okay with the analysis of the question and the first statement, guys? All of you all? Okay with this? Perfect. Now let's go to the second statement. The second statement says the remainder of b plus b by 3 is 2. Now think about it, okay? If the remainder of b by 3 is 2, this side is always going to give me an overall remainder of 0. Because if the remainder of b plus 3 is 2, think about it, it's going to be 1 plus 2 divided by 3. So the left hand side is always going to be fixed to be an overall remainder of 0. Because 10 to the power of a divided by 3 gives me a remainder 1. B divided by 3 gives me a remainder 2. So 1 plus 2 gives me 3. And the overall remainder will be when 3 is divided by 3. So the left hand side here will always give me a remainder of 0. Now whatever value I take on the right hand side for a, right, this value will either be 0 or it's going to be 1 or it's going to be 2, right? If the left hand side is fixed to be 0, I can't say that whether 0 is greater than 0. If I say 0 greater than 0, it gives me a definite no. Can 0 be greater than 1? Definite no. 0 be greater than 2? A definite no. So the second statement gives me enough information to say that the left-hand side of the question is fixed to be 0. Now, if the left-hand side is fixed to be 0, the right-hand side can be equal to 0 or greater than 0. So if the right-hand side is going to be equal to 0 and greater than 0, if I try answering the main question, this answers the main question with a definite no. And a definite no is a definite answer. So the answer here has to be B. Okay with this, guys? Remember, when you're working with the second statement, it tells you that the left-hand side of the question is fixed to be 0, right? So the left-hand side is fixed to be 0. The right-hand side can only be 0 or greater than 0, right? So if I answer the main question, it's going to give me a definite no to the main question. So the second statement individually is sufficient to get to an answer. Okay with this? So again, what happened? I coupled the process of breaking down the question stem with a data sufficiency, and within the statements of a data sufficiency also, you had to make an analysis on the information that is provided. Okay, so what I did in the second step, let me, erase the data that is here. See what I did in the second step. The question is the remainder of 10 to the power of a plus b divided by 3 larger than the remainder of 10 to the power of b plus a divided by 3, right? I've boiled it down to the remainder of 1 plus b by 3. Remember, 1 plus b by 3, and the remainder of 1 plus a by 3. Now the second statement told me that the remainder of b by 3 is 2. So remember, if a remainder of b by 3 is 2, the remainder of 1 by 3 is 1, the remainder of b by 3 is 2. So the overall remainder on the left hand side will be 1 plus 2, which is 3. 3 divided by 3 always gives me a remainder of 0. So the left hand side of the question is always fixed to be 0 by the information that is provided in the second statement. Now the question is asking me, is this greater than the remainder when 1 plus a is divided by 3? Now if the left hand side is fixed to be 0, the right hand side, whatever value I take for a, let's take an example. Let's take a is equal to 1. So if I take a is equal to 1, the remainder is going to be 1 plus 1 divided by 3. 1 plus 1 is 2. The remainder when 2 is divided by 3 is going to be 2. So is the remainder of 0 greater than the remainder of 2? Or basically, is 0 greater than 2? I get a no. If I take any other value for a, say a is equal to 2, 1 plus 2 gives me 3. 3 by 3 gives me 0. So the question now becomes, is 0 greater than 0? That also gives me a no. If I take a value of a is equal to 3, 1 plus 3 is 4. The remainder when 4 is divided by 3 is 1. So is 0 greater than 1? It still gives me a no. Since the left hand side is always fixed to be 0, the right hand side can be equal to 0 or greater than 0, right? So the information given in the second statement answers the main question with a definite no. And since this is a yes-no data sufficiency, a definite yes would also be sufficient. A definite no is also a definite answer, right? So B gives me enough information to say no, the remainder of 10 to the power of a plus b by 3 is not larger than the remainder of 10 to the power of b plus a divided by 3. Okay with this, guys? See, Shreyas, this is more to do with see that I'll tell you why I'm doing this, Shikhar. This is more to do with your understanding of remainders, right? As soon as you see a question which deals with the remainder, which is of this form, right? 15 into 15 by 7, or the remainder of 15 plus 15 by 7, right? Your mind should go towards thinking of the remainder rule. The only way you can work with this question is if you know the remainder rule, by heart. So remainder of a into b will always be equal to the remainder of a separately into the remainder of b. And the remainder of a plus b will always be equal to the remainder of a plus the remainder of b. Okay? So if you knew this rule, and when you looked at this question, right, the question clearly falls under this category, right? In this case, it's in the format of a plus. So obviously your mind would go towards thinking of the remainder rule itself. Okay? Exactly. You'll have to remember the remainder rule there. Otherwise, it's going to be a big problem for you to plug in values to get to an answer. You'll have to work with 10 to the power of 10 to the power of something and go on dividing that, right? It's logical, no? 10 to the power of anything is provided that the power is always going to be an integer divided by 3 will always give me a remainder 1. Take 10 for an example, take 100 for an example, 1000, and so on. So it's like this, right? So how do I get 0 here? Very simple. 10 to the power of a plus b divided by 3, right? So the remainder when 10 to the power of 8 by 3 is 1. And the second statement says the remainder when b divided by 3 is 2. So the overall remainder will be when 1 plus 2 is divided by 3. So that's 3 divided by 3. When 3 is divided by 3, that gives me an overall remainder of 0. That's how I fix the left hand side to be 0. This is more to deal with a remainder concept, okay? Okay with this, guys? Rishabh, you can't have the overall remainder to be 3. When you divide a number by 3, 3 by 3, do the long division procedure, right? So 3 by 3 will give me a quotient of 1 and remainder 0, right? When you divide 3 by 3, you're going to get a quotient of 1 and remainder 0, right? So you have to brush up on the remainder concept, I'm guessing. Okay, guys, can we move on to the next question? Perfect. So here's your next question. Again, like I said, spend some time on the question stem, get in the habit of doing so. The analysis of the statements become way simpler. Your 2 minutes start now. All right, you can start typing your answers in the chat window, please. Guys, just to reiterate something, the question is 1 factorial plus 2 factorial plus 3 factorial plus dot 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 dot. So it can be 4 factorial, 5 factorial, 6 factorial till n factorial. Okay, the dot 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 basically says it's a sequence. Definitely, Sankalp. N can also be 2 or 3, right? When I tell you the sum of n natural numbers, right? Then you'll include 1 and 2 also as natural numbers. No, you still use n into n plus 1 by 2, isn't it? So even if I tell you what is 1 plus 2, you're still going to use that concept, correct? Remember, the sum of n natural numbers is n into n plus 1 by 2. So you can take any number from 1 onwards till n, right? So n can also be 1, n can also be 2, n can also be 1 plus 2 plus 3, and so on. Okay, so like I said, let's break down the question first. Okay, now see, most of the questions that I've chosen here, it depends upon your understanding of particular concepts, right? Like in the previous question, I used the concept of remainders. In this question, I'm going to use the concept of factorials. And this is where your preparation, would help you solve such types of questions very quickly, right? Now, for those who don't know how to work with the factorials, there's a couple of properties that I would want to speak about in terms of factorials before we go further, and this will help you maybe in terms of your prep also with other questions. See, I'm just going to list out some factorials. Okay, the value of 0 factorial is 1. The value of 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. And 6 factorial is 720. There are 3 very, very, very basic properties that you can take back when you work with factorials. The first, any factorial greater than or equal to 2 will always be even, right? It's a very logical property, right? Any factorial greater than or equal to 2 will always be even. Why? Because you're always going to get an into 2 in the end when you expand that factorial, and anything into 2 will always give you an even output, right? So any factorial greater than or equal to 2 will always be even. That's the first. Second, n factorial will be perfectly divisible by all numbers from 1 to n. For example, if I tell you 5 factorial will be definitely divisible by all numbers from 1 to 5, because I'm going to have the denominator cancel out with some term in the numerator. So even if I have 8235 factorial, right? This is definitely going to be divisible by all numbers from 1 to 8235, because the term get cancelled out in the numerator and the denominator. And finally, and this is what this question tests you about, any factorial greater than or equal to 5 will always have a unit digit 0. Any factorial greater than or equal to 5 will always have a unit digit 0 because of a combination of 5 and 2 that you can get in that factorial, right? 5 into 2 will always give you a 10, and 10 into something will always give you a unit digit 0. And this question hinges upon your understanding of this. So I'm going to break down the question. If n is a positive integer, what is the last digit of 1 factorial plus 2 factorial plus 3 factorial plus n factorial? So if n was 1, then 1 factorial would be 1. So the unit digit would be 1. If n was 2, then it's going to be 1 factorial plus 2 factorial, which is going to be 1 plus 2, which gives me a unit digit 3. If n is going to be 3, then it would be 1 factorial plus 2 factorial plus 3 factorial. Remember, 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2 is 6. So 6 plus 2 is 8, 8 plus 1 gives me a unit digit of 9. And finally, if n was 4, 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial would be 1 plus 2 plus 6 plus 24, right? I'm only going to deal with the unit digits here because the question asked me for the last digit. So 1 plus 2 is 3, 3 plus 6 is 9, 9 plus 4 gives me a 3 again. And any value that I take for n beyond 4, right? Think about it logically. 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. The units digit of 5 factorial will always be 0. Because from this point onwards, you're always going to get a 5 multiplied into 2, right? And that always gives me a unit digit 0. So the unit digit beyond a value of n is equal to n is greater than 4 will always give you a fixed unit digit to be 3. Got it? So if you're able to figure this out, things become very easy with the statements. Okay with my analysis of the question, guys? All of y'all? Okay with my analysis of the question? Perfect. Now, I'm going to the first statement. The first statement says n is divisible by 4. Now think about this. If n is divisible by 4, the least possible value I can take for n is 4. The next value I can take for n is 8. The next value I can take for n is 12, and so on. So I know if n is 4, it's going to be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, which gives me a unit digit 3. If I take n is equal to 8, it's going to be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial plus 7 factorial plus 8 factorial. And remember, 5 factorial, 6, 7, and 8 all give me a unit digit 0. So the unit digit is still going to remain 3. So the first statement, whatever value I take for n, is always going to end up with giving me the unit digit to end with 3. So the first statement is sufficient, AD. Okay with the first statement, guys? All of y'all? All of y'all? Okay with the first statement? I'm just saying that if n is divisible by 4, n can be 4, n can be 8. If it's 4 factorial, I know the unit digit is 3. If it's 8 factorial also, I know the unit digit is also going to remain 3. Yes? Perfect. Now let's take the second statement. The second statement says n square plus 1 divided by 5 is an odd integer. So remember, when this statement is given to me, I need to look at what values of n can I plug in the second statement which satisfies this statement, right? Sorry about this, guys. This is a slight problem with the bamboo. So if n square plus 1 divided by 5 is odd, what values of n can I substitute in the second statement which satisfies that statement? Anybody? Can you give me a set of values that is going to satisfy the second statement? Perfect. N is equal to 2 will satisfy, because 2 square plus 1 is going to be 5. 5 by 5 is odd. So if n can be 2, the unit digit of 1 factorial plus 2 factorial is going to be 1 plus 2, which is 3. Now the next value of n that is going to satisfy the statement is going to be n is equal to 8, because 8 square is 64. 64 plus 1 divided by 5 is 13. That's 65 by 5, which is 13. So it's definitely giving me an odd number. But I know that if I take n to be 8, it's going to be 1 factorial plus 2 factorial till 8 factorial. I know the unit digit is still going to remain 3, because up till 4 factorial, the unit digit is always going to be 3. Beyond that, it's only going to be zeros that is going to be added in the unit digit. So n is equal to 8 will also remain 3. So any value of n I take beyond this, I know that the unit digit is going to be fixed to be 3. So the second statement is also sufficient, and the answer here is delta. Okay with this, all of y'all? Perfect. Yeah, with 7, it gives you an even integer, right? You can't take that. No, you have to satisfy the statement first, right, Shikhar? That's the rule of a data sufficiency, isn't it? So you have to take values for n which satisfies the statement. So n, if you take 7, 49 plus 1 is 50. 50 by 5 gives me 10, which is not odd, right? So it's not a legitimate value of n that you can consider. Okay with this, guys? Okay with how we broke down the question, and okay with the take back in terms of the unit digit being 0 whenever you cross 5 factorial? Perfect. So here's the last question for the day. I think we can tie up all the loose ends with this question. Remember, what we learned in this entire webinar is for you to spend more time on the question stem and break down the question before going into the statements, right? So here's the last question for the day, and retired GMAT question. So your 2 minutes start now. Okay, guys, you can start typing your answers in the chat window. Final 30 seconds. Perfect, Shikhar. That's the best way to solve this. All right. So let's have like a discussion on this question. It's a very, very simple one once you break down the question stem based on the information given in the statements. See, sometimes, right? Sometimes what happens when you work a data sufficiency question, it again makes sense to look at what information the statements provide. Because if you're able to transform the main question stem to match with the information that the statement provides, then the analysis of the statement becomes much simpler. You see what the question asks you here. It took Carlos half an hour to cycle from his home to the library yesterday. So the time taken is half an hour. And the question is, was the distance he cycled greater than 6 miles? So the question is about distance being greater than 6. So instead of you, and when you look at the when you look at the statements here, right, you'll realize that the information the statement provides is not in terms of distance, but in terms of speed. So it makes sense for me to take the question stem and to transform the question stem into information about speed rather than information about distance. And this is where the conversion comes in handy, right? Remember what the information provided in the statement tells me is the speed is 16 feet per second and 18 feet per second. So I'm going to change this distance to speed and I'm going to maintain the same units that the statements provide, that is feet per second. So I'm going to break down the question. Is the distance greater than 6? Remember guys, speed is equal to distance by time, right? So if speed is distance by time, distance is going to be speed into time, right? So speed into time is going to be greater than 6. The time is half an hour. Remember, I need to change this to seconds. So how do I change half an hour to seconds? Guys, how do I change half an hour to seconds? Yes, or if you want, you can work with this directly, right? Let's take the time as half. So speed into half greater than 6. So is the speed greater than, remember this is 6 miles, right? So the question is the speed greater than 6 or 12, 6 into 2, which is 12 miles per hour. So I'm changing the question to is the speed greater than 12 miles per hour. Now I'm going to change this 12 miles per hour into feet per second. I've been told that 1 mile is 5280 feet. So 12 miles will be 5280 into 12 feet. So 5280 into 12. And remember, it's 12 miles per hour. So this is 1 hour. 1 hour is going to be 60 into 60 seconds, right? That's 3,600 seconds. I'm going to simplify this. 6 ones are 6 twos are 2 ones are 2 30s are. I can simplify this as 3 tens are 3 ones are 3 sevens are 21, 3 sixes are 18, which gives me 176 by 10. So the question now is transformed to, is the speed greater than 17.6 feet per second, right? The question was previously, is the distance greater than 6? I changed it to, is the speed greater than 12 miles per hour? And then I converted the miles per hour to feet per second because the statements gave me that. So 12 miles per hour is 17.6 feet per second. Now I'm going to look at the statements. The first statement says the average speed at which Carlos cycles from his home to the library was greater than 16 feet per second. So the first statement gives me S is greater than 16 feet per second. And the question asks me, is S greater than 17.6? Clearly, I can get a yes and a no. So insufficient is the E. The second statement says the average speed at which Carlos cycles from his home to the library was less than 18 feet per second. So again, if it's less than 18 feet per second, it can still be greater than 17.6 if I take a value of 17.9. It can also be less than 17.6 if I take a value less than 17.6. So clearly, the second statement is also insufficient. Now, when you combine the two statements, the first statement says S has to be greater than 16. The second statement says S has to be less than 18. I can still pick a value which is greater than 17.6. I can still pick a value which is less than 17.6, which satisfies both statements simultaneously. So even the combined statements can be eliminated. So the answer here has to be echo, right? So one important take back here is you'll have to be open with how to work with your statements, right? And open with how to work with your statements on a data sufficiency, and also to open to how to work with your answer choices in a problem solving question. Whenever you see a question, never just jump into the question directly. Always glance at your answer choices, always look at the statements, and try to correlate the information that is given in the question with the information that is given in the statements or the answer choices. Things become easier to break down the data sufficiency or to analyze a problem solving question if you spend some more time on the question stem. And the second, guys, remember, whenever you work with questions where you have fractions, the denominator is always your friend, right? The denominator gives you huge pieces of information. So make sure you use the denominator to your advantage to get to an answer very quickly. Sometimes to bypass calculations, it makes more sense to think about the units digit and work with the units digit, because the unit digit will help you, reduce the amount of calculation you're going to do, as long as you see that all the answer choices are going to have different units digits. All right. And the big take back, whenever you work with the data sufficiency, spend some more time on the question stem. Try to break down the question stem to a much simpler form and try to correlate the information in the question stem with the statements to get to the answer directly. Okay. So that's the take back of today's webinar, and that's how you leverage the information that is given in the question to get to an answer very quickly. Okay. So final call for doubts, guys. Any quick questions that you have for me that I can resolve in 5 minutes? You can quickly type that in the chat window. I'll be happy to answer. Oh, thank you, Ghanshyam. Thank you. Guys, any other doubts? Any specific doubts that you want me to clarify in terms of prep, or in terms of, asking me anything dealing with the questions that we've dealt with in the webinar? No questions? Perfect. So then we'll wrap up the session today. Great. So I'll see you then in another couple of weeks' time. Enjoy the weekend, guys. Good afternoon again. Take care.